Now that we're updating the cache when we create a new track, let's do the same for deleting a given track. So let's head to our delete track component. We'll make sure to remove refetch queries, or at least comment it out. Then we'll add on our mutation component the update callback. And once again, we'll reference a new function called handle update track, or rather handle update cache. So let's create this function above our return. Once again, it accepts the cache as well as the response from the mutation. And now we're going to be doing the opposite of what we did for updating the cache for create track. Instead of adding a new item to our get tracks query, we're going to remove the item that was deleted. So to read that query, we'll say cache.readQuery and pass to the query attribute get tracks query. We'll get back our data in a data variable. And once again, we'll get our tracks array back on data.tracks. So we want to iterate over this tracks array and find the element with the ID equal to the deleted track ID. So we'll say data.tracks.findIndex. We want to find the index of that track in our array. So we'll search through each track and we'll compare track ID and see if it's equal to the deleted track ID. So once again, we can destructure response, get back data, and since the mutation here is delete track, on data we'll have a delete track object. So then we can say, is the given track ID equal to delete track.id, or rather track ID. And note that within our cached tracks array, all of the IDs are going to be strings as compared to the track ID, which is going to be returned as an integer. So to convert each track ID to a number, we can use the number function or constructor, like so. And once we find that particular index from our findIndex method, we'll put it in a variable called index. And then we can say, in order to remove the track with the specified index, we can say data.tracks and use the splice array method, where to remove that particular track, we can pass in the found index in our index variable. And to specify that we want to just remove one element, we can pass in 1 as the second argument. Even this approach would work to remove our desired array element. Splice is an array method that mutates the original tracks array. So instead of this approach, in order to remove the array element at the given index, we're going to construct a new array, and at the beginning of the array, we're going to grab all of the array elements up until the index, and then the rest of the array will be constructed out of elements that are immediately after the index, or rather the element at the specified index. So we'll find the index, grab all of the array elements up until the index, omit this particular element, and then grab the rest of the array until the end. So we're going to grab that first section by taking data.tracks and using the slice array method, which doesn't mutate the tracks array. We're going to slice from the beginning of the array at the 0th index up until the found index. And since we have now an array within an array, since slice returns an array, we want to spread all of the individual array elements that are returned from slice into this new array. So we do that with the help of this spread operator. So this creates a new array of elements from the beginning of the array up until the element that was found. We'll then omit that element and then slice after the element to the end with data.tracks.slice from, and to get the index value immediately afterwards, we can just say index plus 1, and then by default, slice is going to cut our array from the starting point all the way to the end. And once again, we need to make sure to use the array spread operator to spread that in. So we're putting all of the array elements, all of the tracks except the deleted track, into a new array, which will be put in a variable called tracks once again. And then to write this value to our query, we can say cache.writeQuery. Again, provide our query as the getTracks query. And then for data, we'll provide on the data object our updated tracks. Now let's save delete track. Once again, make sure that we have refetch queries commented out. And we'll try deleting a track that we had previously added. Let's try deleting our first track. So once I hit the trash can button, this track should be immediately removed, and it is. And finally, I want to touch on why not every mutation requires an update function. As we saw with our create-like and our update track mutations, neither one of them needed to have our update function added. And this is a particular quirk of working with Apollo Client that's worth knowing. It's a result really of how Apollo chooses to manage its cache, and it has something to do with how our mutations are constructed. Namely, for any mutation where we're updating an individual item and we're returning the item's ID as well as the properties that were updated, and you can see that both of the things I mentioned are the case with our create-like mutation. In that case, we don't need to have update, and our UI will update immediately when we execute this particular mutation. So make sure to remember this for future projects. Whenever you have a mutation that updates data that you have within your app, to see changes applied immediately within the browser using the Apollo cache, make sure that you're returning the item's ID as well as the fields that were updated.